Alright, so I'm going to describe how this DC motor works. So here we have this plastic tube here, and this is the rotor of our motor. It's the thing that has a torque applied to it, and it accelerates and rotates around with some angular velocity. Now let me describe how this works. Here we have a reed switch, and here we have a stator coil. Now, here, the stator coil should be producing a south pole magnetic field. And here you see on the rotor, we have these permanent magnets and the south poles facing out. So, if you have a south pole on the stator here and a south pole on this permanent magnet, then the south pole of the stator repels the other south pole on the rotor, and we get a torque on the rotor, and that propels the motor forward. However, there's a problem with this, and the problem is that if you just thought of that as being the case, if there's a south pole here, then as the rotor rotates here, right here, the stator will be repelling the rotor in its direction of motion. If it's moving in this direction, then here, right here, the south pole of the stator is going to be repelling the south pole of the rotor magnet here. And then once you get to here, now it's pushing along the velocity and speeding it up. So here it slows it down, and here it speeds it up. So here it would slow it down, and then here it would speed it up. And so because of this, you get a negative torque here, and then you get a positive, and then the torque goes to 0, and then I get a positive torque here. And so there shouldn't be any net torque. However, there actually is a net torque for another reason, and it has to do with this reed switch here. This reed switch has a kind of asymmetry in it. So let me demonstrate what that asymmetry is. And it's mainly how the reed switch closes. So let me make sure the reed switch is properly working. Alright, it seems to be properly working. Alright, so what happens is, only the stator field is produced when this reed switch is closed, because when the reed switch is closed, it completes the circuit and allows current to pass through this coil here, producing a magnetic field, right? And that magnetic field is a south pole, so it repels this south pole, these south pole magnets here. Now, if you carefully observed the reed switch as we rotate the rotor, you'll notice something odd happens. So right here, this other south pole on the other side of the stator, is what closes the reed switch when it gets close enough. So when this south pole gets close enough, it clicks the reed switch, right? Clicks it and it closes it, and now we have a stator field here. Right, so that occurs at about right there, and that's about 1 degree from this south pole being parallel with the stator here, right? So here the reed switch is closed, and the torque and the torque is negative here because it's repelling from the stator coil. It's repelling this magnet from the stator coil. Now, what you can actually do is you can keep rotating it, and if you observe the reed switch here, you can keep rotating it and rotating it and rotating it, and boom, right there, it now is open, and we rotate it for about a whole 45 degrees. You can see the motor, the permanent magnet here is at about 45 degrees. While it closes at about 1 degree, you can get the rotor, the reed switch here stays closed for a whole 45 degrees, and because of that, we get more positive torque than negative torque, and so we have a net torque on the rotor, and that's really why there's a net torque, and why it actually accelerates the rotor, and it reaches some synchronous speed and maintains a steady speed at some voltage, and that's how the motor works.